All right, so here we have how much work is needed to accelerate a 50 kilogram object from 3 to 8. So we can think of this as a box, though it doesn't have to be a box. It's any object moving in any direction. And I want to accelerate it from 3 to 8. So if you do think it as a box, it's the box over here has an initial velocity of 3. And then I'm going to accelerate it to a final velocity of 8. And this happens, you would imagine, by pulling it this way, since I drew the second point on the right. And I want to know how much work is done. Notice that it's not asking how much work is done by F, just how much work, period, irrespective of how many forces there are. So it's implied here is that we're asking for how much total work is needed. In other words, what is work net? Now remember, there's 3 ways we can find work net. Work net could be the sum of all the individual works. It could be the work done by the net force, if I can get that, or the change in kinetic energy. In this problem, since I'm giving you the velocities and you have the mass, this is the best way. And actually, in this one, it's the only way to do this. Okay, so it's very straightforward. It's just going to be K final minus K initial, and I have all the numbers. Half mv final squared minus half mv initial squared. You could factor out the half m if you want to. It would look like this: half m v final squared minus v initial squared. You don't have to do that, but you could. Half the mass is 50, and the velocities are, setting it up here, the velocities are 8 and 3. 8 and 3. And if you do this, you get a total of 1375 joules. So the net work is 1375 joules. Just very straightforward. Just plug and chug into the equation. That's it for this one.